Hey guys, so this is what we're going to see. We're going to see what is a partial fraction. Okay. No, so the partial fraction, or in simple term, the composition of a fraction. So it's the process of breaking down a fraction into one or several simpler fractions. Okay, and this is the representation of partial fraction. You can see. So we're going to represent this partial fraction. So initially we add this fraction, and then we can write it in this. We can break it down in this form. Okay, and if you add those two, okay, if you want to verify those two, if you add those two, you'll get back to this initial fraction. Okay, just for verification purposes. So as we're going to need this type of fractions, okay, and we're going to use them for when we'll be working with inverse Laplace. So when we'll be working with inverse Laplace, okay, and when we'll be working with Z transform inverse. Okay, so when we be working with also with Laplace, inverse Laplace, and also inverse Z transform, that's when we're gonna need this to break down the fraction. And this is because if we don't get the form, this form is not inside any table, Laplace table or Z table. That's why we're going to break it down into and decompose it. So you need to know this in order to solve those questions. But just to give you an idea that there are different types of partial fraction. Okay, we have the linear factor, we have a repeated factor, and improper factor, improper partial fraction. Now let me just remind you, we're not going to be working with this type of improper partial fraction, because most of the example that I will give you, we're not going to be using those methods. It's actually quite complex, and also you can see the numerator is very the power of the numerator is very high. Okay, it's very high compared to the denominator one, so we're not going to be focusing on this. Okay, as we're going to keep our focus on the linear factor. Okay, so and also repeated factor, so where the numerator it's low, it's the denominator has a higher power compared to the numerator. You can see that this one is you can even see that. So this is the type of example that we'll be working on, and this just to give you an idea of how we went from here to this and how we move from here to this. You see repetition, so that's why you see we have A, B, and then you can solve for the unknown. So I'm giving you the table now. Later on I'm gonna show you how you can apply this table into the equation. So we got more formulas here. Okay, these are the general formulas that you can use for partial fraction. Okay, I'm going just to put like this so then you can see both at the same time. So, and then zoom in. This is when you have this type of equation. Okay, and this is how you're going to break it down. Okay, so you can see the denominator power 1, and then it's gonna break it like this if you want to know what's going on. So this is what it's gonna do. And if you have a form like this, you're going to break it into 3 and then write it in this form. Okay, and if you got a denominator like this, you can write it either in this form. You just need to decompose the term inside, okay, to factorize, and then you're going to get this form here. Now we do the same for this one. This is a repetition partial fraction. That's why you see we're going to write it in this form, because you have power 3, so you're going to write power 1, power 2 until you get to power 3. Okay, that's what happened here. You see, so we just break it down and then write it like this. But now we, in terms of power, you go next, we got this example, you got this one, you can write it in this form when you take x out, and then you can also, because of x squared, you can write it like this, x squared. Okay, and then you're going to add this after that. Let's move to this side, and here we got this form. Then the way you're going to write it down, it's gonna be this one, you write the first one and then the second one here. We couldn't separate them because of 6, so there's no way that this is not 9, it's 6. That's why you see we're going to write this form on top. Okay, and here x cube, that's why you see we have 1 2 3. Okay, and then we got this like this because we can't separate, this is 2, we can't factorize it. Now for this one we got the same 2 powers. Okay, we start with the first one and second one, and because of this we can break it down. That's why you see we have a times x plus b c x times t. Okay, and further on, this is what we get. You have this one, and then you write the first one, you're done, you move to the second one, but we see the power that we're going to write first, power of 1 and power of 2, and because there's a 1 inside plus 1, that's why you see we have this one on top. And last thing, when we get something like this, you're going to break it down into this form. Okay, and this is factorization, and then you're going to break it down like this, and then you can have each of these terms over a number. It's gonna be a minus 1 plus b 1 plus x plus c 1 plus x squared. So, and then because we have 1 here, so it's gonna be like, we're going to write it in that form, if I'm not mistaken. Okay, so it's gonna be something like this. Yeah. So in short, let me just give you a general idea. This is what we just saw, and then we're going to use those rules later on. I'm gonna give you some example where you can actually see how we can remove or break down the equation that we're going to get. Okay, so I believe that this is gonna be more general, and all the example that I give you, or everything that you have seen, this is what we're going to use. Okay, and not just in any question related to partial fraction, we're gonna use this form. I'll provide you 2 methods solving them. Okay, so, and remember that we're going to focus more on these 2 types. Okay, and we will avoid this improper partial fraction where the power of the numerator is higher than the denominator. Okay, so this is it. So let's get right into it.